Hello everyone, I'm Robert Steven Santos from grade 12 St. Clement, and for today's video we will discuss about the vectors, Newton's law, motion, and measurements. And physics is the scientific exploration of fundamental law that govern the universe. It delves into the mysteries of nature, from the tiniest subatomic particles to the vast expanse of the cosmos. At its core, physics seeks to understand the very essence of reality, uncovering the principles that shape our world and the forces that drive the cosmos. With physics, we can solve a lot of things. That they say that physics is everywhere, yeah, like that. And for our first discussion, we will discuss about the Newton's law of motion, the law of inertia. And without further ado, let's get into the topic. And for our problem, we have a car is traveling on a straight and level road at a constant speed of 65 miles per hour. Suddenly, the driver slams on brakes, bringing the car to a stop. Explain the car's behavior using the Newton's law of inertia. We have here our formula, the F net equals to the mass multiplied by divided by acceleration. And did you know that Newton's first law of motion, also known as the law of inertia, states that an object at rest will remain at rest, and an object in motion will remain in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. In this scenario, the car's behavior can be explained with the specific numbers follows. The car is initially traveling 65 miles per hour, and it is motion according to the Newton's first law. It will continue moving in the same direction unless acted upon by an unbalanced external force. When the driver stops or slams on the brakes, the car brake system applies unbalanced external force to decelerate the car. Let's assume that the exert of a force of newtons is negative 600 newtons in opposite direction of the car's motion. The negative sign indicates that the force opposes the car's forward motion. And the mass of the car is 1600 kilograms. The car's resistance to change in its states of motion due to its inertia, a property of matter described by Newton's first law of inertia. Since the car was initially moving at 65 miles per hour, it tends to remain in motion at the same speed in the same direction unless acted upon by external force. Like as I said earlier, coming to a stop, the unbalanced force by the brakes, the negative 6,000 newtons, overcomes the car's initial state motion. According to the Newton's second law, if we assume that the car's mass is 1,600 kilograms, the deceleration can be calculated as negative 600 newtons divided by 1,600 kilograms is equals to negative 3.75 meter per second square. This is this is our final answer for the law of inertia. The car decelerates at the rate of negative 3.75 meters per second squared, like I said, and eventually comes to a complete stop during deceleration. The car's speed decreases gradually. In summary, The car's behavior when the driver slams on the brakes can quantitatively explained by Newton's first law of inertia. The car's initial speed was 60 miles per hour, and the application of brakes provided an unbalanced force that resulted in deceleration of negative 3.75 ms squared, ultimately bringing the car to a stop. This demonstrates the concept of inertia and how objects tend to maintain their state of motion unless acted upon the external force. For our second Newton's law of motion, the law of acceleration, we have here our problem. A 500-gram object is subjected to a force of 30 newtons applied horizontally. Find the acceleration of the object. The formula that we will use to this problem is the F net equals to mass divided by acceleration, and our given is F because 30 newtons, the mass is 500 grams, and F is the force applied in newtons, so like the newtons, and M is the mass objects. A is the acceleration, right? Like, yeah. In the problem, there's a 300 newtons given, but we will gonna convert it to 30 newtons, and we need to convert the 500 grams into kilograms. When we convert 500 grams, 1 kilograms is equivalent to 1000 grams. So 500 grams is equivalent to 0.5 kilograms. So you're just gonna 500 divided by 1000, and this is gonna be the answer. So we will compute the formula to find our answer. Acceleration is equals to mass, I know, F net divided by mass is equals to accelerate A equals to 60 m squared per second. This is our final answer for this second law. While in motion, certainly here's an one-dimensional motion problem and solution. Problem: an object is initially at rest. It accelerates at a rate of 4 meter per second square for 5 seconds. Calculate the velocity of an object. Our given is we don't have any final velocity because this is gonna be this is we will gonna find, and the initial velocity is 0 because the object is at rest. Like, the acceleration is 4 ms squared while the time is 5 seconds. Now, this is the formula for our 1D motion, right? So we're finding the final velocity. So initial velocity, which is 0 ms squared plus 4 ms squared multiplied by 5s is equivalent to 20 ms, and 0 ms plus 20 ms is 20 ms. This is our final answer. So that is for the motion. So for the last, uh, the vector. So a hiker walks 3 kilometers north, then 4 kilometers east, and finally 2 kilometers south. Calculate the hiker's displacement from their starting point. First, find the hiker's total displacement in the x direction with the east and the west. So this we have the 4 kilometer east and 0 kilometer west is equals to 4 kilometer. This is 3 kilometers north equals 2 kilometers south. So this is equivalent to 1 kilometers. So with our formula, we're gonna use d is equal to the square root of d squared x plus d squared y. So the square root of 4 kilometers squared plus 1 kilometer squared is 4.12 kilometer. So the hiker's displacement from their starting point is approximately 4.12 kilometers, and the direction of displacement can be found finding the angle with respect to the x-axis. So this is our final answer to this problem, which is the vector, and that is the end of our discussion for today. So I hope you learned something from me. Again, I am Robert Steven Santos and from grade 12 St. Clement, and thank you.